Greetings, Padawans. This is Cisco Jedi Real World Mission. This is going to go through the live turn-up of a branch office. Thought this would be a great exercise for CCNA. Let me first apologize in advance for the fans. I'm sure you hear them blowing. I'm in a server room right now, so I've got a bunch of stuff blowing in my mic and in my ear. Best I can do, getting as far away as my console cable will let me. So, a little bit of an unusual situation. I'm doing this kind of as a favor for a colleague. They are working with a local service provider, but they don't have any information on what the customer network will be, what their LAN subnet is. So I can't necessarily go through the whole branch office, but I'm certainly going to go through the T1, make sure the internet is pingable. However, things like NAT or any ACLs, I can't really do too much because I don't know what their subnet's going to be. But we can go through some basic configuration, some basic hardening, and I think this will be a great exercise since a lot of the CCNA materials don't cover configuring a T1 interface and you don't get much exposure. So this also uses the newer syntax. Legacy syntax use something called, or the command set T1 controller. This is not using that. This is all going off of the interface context of the serial interface using something called service module. So you'll see that as we go along. So kind of just one slide here for today. We're configuring a Cisco 1841 with the T1 WIC card, and the battle plan is pretty simple. We're going to do a basic setup, then we're going to do the T1 portion of the config, and then we're going to do some basic hardening on both the T1 WAN interface as well as the router itself. Again, we can't do a lot. I can't do NAT. I can't do ACLs because I don't know what the LAN is going to be. If they're going to set up remote access VPNs, any of that, have no idea what any of that information is. But we will do what we can. So let's kind of just go through here. Let's just go to enable. So, pretty much a version here. Let's do a show version real quick. So you can see 1841. It's running version 12.4.13. A little bit older. This is a refurbished router. It is running the advanced IP services set. So this does support things like, for instance, the CBACs or even potentially the iOS intrusion prevention. Lots of good stuff that it would support here. Kind of just going through this. So that's the show version. That's what we have. So let's start going through and do the basic router configuration. All right. One of the first things we want to do, this is a customer router, so I would say let's define a host name for him. And we'll say LAX 1841 MPLS. Should be pretty straight ahead. Now that portion of it's going to come later. We are just going to do the T1 for right now. So they're going to actually, once this is set up, tie this into the BGP config, let them distribute routes into a MPLS VRF, or a VPN if you will. None of that is in scope for now. Just getting that T1 up and running is really all we want to do, and do a little bit of basic lockdown, since this might be online for a couple days before the customer does anything with it. And in case any testing is done, try to do what we can to prevent the router from being owned sitting out there on a public IP. So first thing I like to do is go through the basic services that we have. So first thing we want to do, Nagel, this is an old one. What this is going to basically do is kind of help reduce redundant transmissions of small packets for things like Telnet. Since this is going to be accessed remotely for configuration, I like to do that. And then another one is also TCP Keep Alives. Again, a session that's currently active with Telnet or SSH, it can get it's more easily or more likely to be corrupt. This kind of helps that with the keep alives and whatnot. Another thing we want to do is have timestamps on our debugging messages or any logging messages. This is all kind of basic stuff that you would do for any router, right? So I think it's date time MSEC. So that's the timestamps on the debugs, and then timestamps on your logs. Same deal. All right. Let's see. We want to set the time. What is my time zone here? So PST. We're in Los Angeles. That's -8. And then clock. Summertime. I think that's it until. Summertime. Yes? No. Nah. There we go. So that will set up the dates and whatnot. Okay. Alright, now what we want to do is set up logging messages. We want that to be sent out to the terminal. So when you're doing debugs and whatnot, we want to see those messages. The two main things that you have, there's logging console and logging monitor. Monitor is going to be used for telnet sessions, SSH sessions. Console is what we're doing now when we're consoled into the router. So let's actually set those up. So logging console. We'll do notifications. Debugs might be a little bit too intense. Actually, you know what? For now, we're going to set debugs because I want to see them in case they need to troubleshoot. And then terminal monitor. Oh no, we have to go into exec mode for that. For instance, something like that. Alright, it's already in monitor. Great. Alright, what do we want to do now? We want to be able to have it create kind of like a local cache of logs for certain specific events. This one maybe will do only warnings, so that's what buffered is. In the local buffer, we'll set it to 51,200. That's the recommended size. And we're just going to do warnings for this. We're not going to need to see all of that. The logs will fill up too quickly. But if we get warnings, that should be sufficient enough to look back for a historical purpose and see, hey, what was the problem? What's going on here? Another thing we might want to do is just set a backup account, which I would, give the credentials to my buddy. So username, admin, privilege 15, so it is a admin account. Secret, you don't want to do password here. Secret will do an MD5 hash, which is actually on newer routers being deprecated for SHA-256 now. And we will just set this out to be something, something silly. He can change it up later. Alright. So, let's see, there's a couple other things that we can do for right now, but we'll go through that in the hardening later. Right now I want to start with the meat of this, which is the T1. So let's exit out of here, do a quick write mem. Oh, one other thing I want to do, no IP domain lookup. I'm sure you've done this before where you type in a command and what is it? Oh my god, it's taking forever because it thinks it's a DNS name. This will prevent it from doing domain lookup. So if you accidentally type in something incorrect, you're not going to sit there from now until the end of the earth waiting for that command to resolve. So let's do that. Set it here. Alright, now before we get started, I want to set up some debugging. So as we're activating this, we will get some information and see some screens. There's not a lot with serial interfaces. So let's see here. So debug serial. So event, what else do we have? Interface is one, and then I think there's interface counters or interface conditional. So we'll do interface and interface conditional, and then packet. That should be a good amount. Alright, and then last we're going to do debugging for service module, and that's really it. Okay. That's it. That's all we got for the debugging. So as we configure this, hopefully we'll get some status messages. So right now, let's do quick a show IP int brief, show IP interface brief, and that shows everything is down. We've got a fast Ethernet 0, nothing's 1, and serial 00. What we don't see here is, well, that's a serial 0 interface. How do we know, checking remotely, that this actually has a T1 card? What if I do show interface serial 0? Not really going to tell you that. Not going to tell you it's T1. You can certainly say, well, the bandwidth is the same speed as T1. Oh, look at that. Integrated T1. I lied. I made a ladder, but it does show you. But the other command that you would want to do for seeing layer 1 packet or error information would be show service module. This guy here is your friend. So he's kind of telling you through that. And right here, this tells you it's a T1 interface. This kind of gives you some information if there's alarms or whatnot, which, there's an alarm now because we're not up. But, you can see here if you're getting frame loss, you can see specific information on the packets and the counters right here. So this is probably one of the more useful commands if you have to troubleshoot this remotely. So let's, without further ado, go into our configuration mode and start configuring this guy. Alright, so we're going into to serial 00. As you know, or as you may not know, if you don't know, there is going to be another Cisco Jedi video coming out explaining the theory behind T1. However, this kind of coming first. This is assuming that you know T1 is made out of 24 channels, those 24 DSO, 64K, or 56K, depending on your signaling method channels. So first thing you have to do is define that, because you could potentially be having fractional T1 and using only 8 of them or 12 of them. So let's first define that. So all of these commands that we do right now to configure this are going to start with service module T1. All right? So the first thing we want to do is define those channels, and it's time slots is the syntax here. Time slots, you could do all or 1 to 24. I'm a nerd, I like my details. So 1 to 24, you define the speed. And again, depending if you're using raw bit or if you're using out of band signaling or CAS or E&M, whatever the case is, it could be 56K per channel or 64. In this case, I know because I got the information from the service provider, who will be giving you this information, it is a 64K channel. So that's the first thing we have to do. And right now what we're getting is those debug messages. Alright, so service module T1. Next thing we have to do is define the framing. Now by default, it's going to have extended super frame framing. It's going to have bipolar 8 with 0 substitution line code, and those aren't things that you normally have to define. But to go through the motions and make things specifically exactly what we want, we're going to do the exercise new. But you can tell when we looked over here, that was show interface. Where is our show service module? Here we go. It tells you that you're already in extended superframe and binary 8 or bipolar 8 with 0 substitution. We're going to go do through that exercise though anyway. So T1 framing ESF, especially if you have to configure something else. Just to show you the options, superframe and extended superframe. I haven't seen SF since the 90s. So service module again. And again, those are just the debug messages since we're seeing every detail. Line code, and we have ANSI or AMI or bipolar 8 with 0 substitution. We're doing the bipolar 8 with 0 substitution. Alright. Next thing that we have to do that's very important is who is he getting his synchronization from? The service provider is the one providing the clock. In 99.99999% of the situations, you're going to sync to them. Remember, with digital synchronous situations, one person is the slave generating the clock, the other person, or one is the slave syncing to the clock, one person is the master generating the clock. In this case, we are synchronizing or slaving to the service provider. So what we want to do is tell him that, hey, your clock source, you have two options, internal and line. We're telling him, go to the line. Don't use your internal clock. Go to what the other guy's providing you, so you'll be in sync. One other thing that we might want to do here, I actually happen to know that this line is pretty short. This is much, much smaller than 100 meters, certainly. This room is actually right over the service provider. There's literally a hole dug into the floor, not even using conduit. So we want to specify the cable length here so it doesn't necessarily send a signal that's too strong and potentially corrupt the signal sent. So we want to specify cable length, and I think it's 110. Yeah, shorts 110. Let's show you your options here. Yeah, I don't even think we're 50 feet, to be honest with you. So we'll do that so it obviously attenuates the signal correctly. All right. Last thing we want to do is the IP address, which I know, again, getting that information from the service provider. So that is 69.10.128.6, and it is a /30 mask. And then we know shut him, and that's it. So we're going to start, we're getting some messages now. Now he's up, and you can see right now he's starting to synchronize. He's down. Give it a second. The clock sync. There we go. We are up. See that? We are up. Up. All right, so let me see. I know that my next hop router is actually going to be the other one in that /5. So again, these are the debugs going up, so we actually get this status. I'm going to do this now. Do no debug all, because I don't want to see these anymore. Thank you. Come again. So let's see, first of all, let's do a write mem real quick, save our work. Let's see if I can ping my neighbor. Okay. 69.10.128.5. Yes, I can. So let's quickly set up our default route. And that is going to be 69.10.128.5. So let's make sure I can, for instance, ping 8.8.8.8. We're good. We are good. We have internet access. So let's do write mem. So the core of this exercise, setting up the T1 interface, we are good to go. But since we're good little Jedis here, we're not going to leave the router necessarily in this position. We're going to do a little bit of hardening as well. So let's go back into configuration mode. Okay, so certain things that we want to do. Let's start with some of the things that are specific to the WAN interface itself. We'll go through and do some hardening, but since this interface is facing the public, the first thing I would say is let's look at the WAN interface and see certain things that we can remove here. One of them, no CDP enabled, no reason to broadcast information out. There's quite a ton of things. By default, he's going to proxy ARP requests. So we do no IP proxy ARP. Sure, you know what that is. So that means he will respond on behalf of others to ARP requests. All right. Another one, no IP redirects. Let's see what else. No IP directed broadcast. I think that's another one. There's another one, and no IP unreachables. This is basically trying to protect against vulnerabilities built into the TCP/IP protocol. You know, it wasn't initially designed in the 60s and 70s to be secure. It was designed to facilitate data. There were 20 machines that were using this when it was originally conceived of, all kind of government or college. So, there's certain things that can be exploited. How ARPs are responded to when a system is looking for who owns this IP address, who's the MAC for this IP or whatnot. So we want to prevent that. IP redirects, being able to control the traffic, directed broadcast. I'm sure you can just imagine the pain that would cause if you're able to say to have the response of a broadcast query, the 255.255.255.255, or the broadcast of a subnet, and have that flow to another source, especially by packet headers, i.e. the traffic is dictating that. Not a good thing. Not a good thing at all. So we want it to block that. The last thing I'm going to put here is something that you'll learn about when you start studying multicast, or to go deeper into security. It's called unicast reverse path forwarding. And what this does is it looks at where the traffic came from and compares it to the routing table. How is that relevant? Well, let's say, for instance, we're looking here at our interface 69.10.128, and we see that traffic, but it's coming from fast Ethernet 01 or 00. It's going to look at this and say, wait a minute, according to my routing table, that should actually come from our serial 0 interface. Why is it suddenly coming from fast Ethernet interface? Maybe it's security, maybe it's just bad traffic, maybe it's some corrupt routing tables. Whatever the case is, it's not going to pass. It is going to compare the routing table and then look at where the traffic actually came from. And if it does this reverse check and it does not check out, it will drop the traffic. So those are some basic things that you can do on the interface. Now going through the router itself, there's quite a few things. First thing we want to do is go through and disable services or whatnot that aren't really necessary. So what we can do here, one of the biggest ones you want to do is source routing. Again, letting the traffic tell you, how is this going to route through my network? No, my friend. We never want that. We want our routers and routing tables to control that. These packets are not meant to be like us, unique drivers behind automobiles. We want to control that and not let the packet or the traffic coming inbound override that. So that's one of the things that we do. Another one is gratuitous ARPs. Obviously, kind of the same thing. We want to put the kibosh on that. Let's see, there's some other servers like BootP. Even if you're using DHCP, BootP is kind of the predecessor to that older version. There's no need to have BootP running on here, so you want to disable that. The Finger service is one that I can think of. That basically lets, the Finger service basically will give information about the router to a quote-unquote finger query. I know, it doesn't, it sounds kind of dirty, are you fingering a router? But it just means you're trying to poke it for information. Some other services, IP identity. All of these, by the way, if you want information, Google them. But this is just kind of some basic hardening that you want to do. Another thing is limit the rate of ICMP and reachables, because that can be used as an attack. I'm glad that Cisco has this option. What I'm not glad is that it's only the rate limit. So rate limit, unreachables, only type 3. It would be great if they would do that for all of them. I typically set this to 100. That's totally fine. You should never get more than 100 in a millisecond, much less a second. So those are some basic things that you can do to harden it. Let me see if there's anything else that comes to mind. Let's see. Well, one thing that we know is he is currently responding to Telnet as well. Maybe we should limit that. So here's something that we'll have to do. Crypto key. Is it crypto? Yes, crypto key. Generate RSA modulus 1024. General keys. Yes. Oh, I need to define a domain name. Right. You need a host name and you need a domain name. So let's do this. IP domain name. Stage.net. Now we can go through and do this other one. Now it's going to generate the key. By doing this, it's automatically going to enable SSH on the terminal interfaces. So see that? Just got our alert here. SSH is enabled. So we can do that as well. And let's do that. Line BTY 0/4. Transport input SSH. No telnet here over the internet. Thank you. Login local. We also have to define privilege 15 too, I think. Is that? Yeah. Privilege 15. So when someone does telnet in, they can actually get that access. There we go. All right. Let's save that config so far. One thing that we want to do now, since he's open to the internet, is we want to limit those rates. So what we're going to do is put the kibosh on someone trying to brute force their way in through SSH. So you do that with the IP SSH command. So first IP SSH authentication retries, I believe. Oh, SSH authentication retries. We'll set that to 5. 5 is all you get, just to kind of show you the options here. Yeah, I think 0 to 5 is what you have. The other thing that we want to do is say how long are they going to have to wait between tries, and I believe that's the timeout. Yes, timeout. IP SSH timeout. So we're going to set that to the maximum, which is 120 seconds. So what that means, you do your 5 logins, now it's not going to take logins for another 120 seconds. So you might say you can try 5 attempts every 2 minutes. Is that really cut down on brute force? Absolutely. When someone's brute forcing, they're trying to do thousands a second. So this will definitely put the kibosh. As a secondary one that you can also do as well, that this is just for SSH, there's also security authentication. Failure rate. So failure rate, we'll set that for 5. Log, I think that's it. Yes. So again, any type of authentication, console, you name it, is going to go through right here. Let's see, anything else? Oh, of course, service password encryption. So if they try to set up anything that would have to be plain text, that would be protected. One disappointing thing, password encryption does not encrypt your SNMP community strings. A little bit of a bummer. Because as you know, you sent in the clear text, someone can easily spoof that, but why make it easier for them? So let's do this now. I think that's about it for what we have. Let's take a look Let's exit out of here, do a right mem. And do show run. Let's see what we have here. So just kind of a good exercise, kind of go through. So we have here. Now, last thing I can do, I actually happen to know the range of IP addresses that they would be telnetting from. So we can lock this down even a little bit more, maybe prevent them from necessarily anyone logging in. Even though we protected it from brute force attacks a little bit, probably a good idea to say, hey, you know what, we don't want them to necessarily be able to log in from anywhere. So this is what we would do here. First, we're going to make an IP access controller. So access list, we'll make it 22 for SSH. That should make it easy to remember. Permit, and I believe it is going to be from 65.10.128.0 255.255. Now I have to remember. Stand by. 65 or 69? My mistake, 69. That would have been bad. So they know they're going to be logging in from this one right here, anywhere on that class C. Sorry, I'm looking at my list here while I'm typing this. And then this is going to be 63.234.128. This is, okay, this is a little weird. This is a slash 25, 128.128, so that would be, you know what? I screwed up. I screwed up here. It's actually supposed to be wildcard mask, isn't it? Yes, it's wildcard. So this would be 0.0.0.0.127. And I will redo this guy right here and fix that. We want wildcard masks. So that's 0.0.0.255. And let's see. Do show run, begin, access. Yeah, see, that other one didn't turn out so well, so we will just do this. In PuTTY, you can... See? Good. It's good to mess up a little bit when you do these so you kind of gain from it. So if you highlight this, I'll type no, and then right-click, that line is going to appear. Oh, look at that. Beautiful. And now if I do show run again, begin at access. Oh, it just killed everything. Did it kill everything? Really? Let's verify. It did. Alright, that's okay, kids. Thank you, command history. So that's one, and then the other one is their range. There we go. We should be back in business. So do show run, begin, access. There we go. Okay, we're in business. So now we will go to line VTY04, access 22, and bam, look at that. Now someone can only telnet in from those specific IP addresses. Gives you a little bit warmer, fuzzier feeling putting this out on the internet. Last thing I want to do is just do some quick show interfaces. To one specifically, so show interface, serial 0/0/0. You know, obviously you have this one. Then show service module, serial 0/0/0, performance statistics, and this will let you do it. Typically, if you want to just see one interval, you just do 1-1 to see. This will let you look through and see the errors. We don't really have any traffic going right now. Maybe if I do some pings, ping 8.8.8.8. Can I do a repeat? 99. Okay, good. Now we actually have a little bit more, not much more. I think another thing that we can do also is the show interface counters. Let's do that real quick. Serial 0/0/0 counters, I believe. Counters, yes. I believe by default they're cleared every 5 minutes. What is it? What's the one I'm looking for? Summary. I think summary is it. There we go. There we go. That will go through and give you the stats. Not much, not much, but certainly some things you can do to see how traffic is going, get the errors. Show interface and show service module will give you the most details. Show service module serial 0/0/0. That will give you the most detail in terms of, what's the clock source set to? What is the line code set to? What is the framing set to? What are the alarms that are on the line? And this is about as long as the connection has been live. So there we go. That's about it for right now. There's a lot more that we could have done. If I knew their WAN, we could certainly have set the NAT, as I said. We could have done some CBAC rules to do stateful inspection, not just access lists, but be able to sniff the traffic so it may be filtered, initiated from the outside, but return traffic that's generated from the inside would still be allowed. That might be something for a later lab. Anyway, I think we did a pretty thorough job here considering the limited information we have. We configured the T1 interface. We did some basic security on it and got this guy up and running and allowed it to be accessed remotely, but prevented anyone who really shouldn't be from doing it. We protected it from someone doing a brute force attack. So all in all, not too bad. Anyway, we'll have another lesson, like I said, coming up explaining the theory of T1. In the meanwhile, this is the Cisco Jedi signing off.